Okay, today we're just going to talk about the test that's coming up on Thursday and Friday. It'll pop up on your My Open Math, and you can take it. The length will be 75 minutes you'll be allowed. I'm going to go over some of the key points that will be on the test, and maybe clear up some things and answer some questions. Wait a second. Okay, we started off finding the percent of the total. There's been a few people who have seen to have an issue with this, but the percent in fractional form is always going to be the part over the whole. So if you were sharing, say, 100 pieces of candy and you got 25 of them, the percent that you have as a fraction is 25 over 100, or 1/4, which is equal to 0.25, which you convert to percent is 25%. Okay. Now, here's an example here. 88% of the students of a student's test were correct. There were 50 questions. How many were correct? That would just be 8.88 is the decimal value of the 88%. You multiply times 50 and you get 44. By the way, the great majority of you guys have done like 100% of the homework and are doing very well. So I expect a lot of good grades on this test. Percent change. You calculate the absolute change as the ending quantity minus the starting quantity. The relative change is the absolute change over the starting quantity. That's a decimal. And you need to convert to percent. The absolute change will always either be 0 or positive, but it'll end up being an increase or a decrease depending on whether it goes up or down. Always convert your answer to percent. I'm sure on the test you'll have something about discount prices, sales tax in Washington, 8.1%. What is the state sales tax on a $4,700 car? You would just take 0.081 decimal form times $4,700, and that's $380.70. And then the final cost of the car, you just add the two together, would be $4,700 plus $380.70, which is $50.80.70. If you have any questions, just unmute your mic and ask your question. Now, getting into interest and savings accounts, simple interest is the first thing we talked about. And that's when there is no compounding. You don't add any of your interest back to your starting value, and you start off with a principal, abbreviated P. I is the amount you make in simple interest. P is your principal, R is your rate in decimal, and T is the time in years. And I equal PRT is the way you calculate the interest over a period of time. Now, I noticed in looking at some of the homework that some folks had an issue trying to figure out the total value of an account. If you have simple interest, the total value is going to be your principal plus your interest. So if you calculate your interest using PRT to get your total value at any time, you just added back what you started with. And that ends up being P times 1 plus RT. Now, compound interest, we talk about the present value is that's really the starting principal. That's how much you start with, and you want to figure out the future value at any time T. You use this formula. By the way, these notes can be used when you take the test, so I suggest you print them out and take them with you to the test. You don't have to memorize these formulas. In fact, to be honest with you, I can remember most of these formulas, but sometimes you got to be careful to make sure you memorize it. Some of these can get a little complicated. So I never put a lot of stake in memorizing a lot of formulas. One of the things that some folks had an issue with was how much interest had you gotten on your account at any particular time. Well, at any time, the future value, the value of it is FV. Subtract the beginning amount, what you call the present value from it, and that's be the total interest. And we'll do an example of that in a little bit. A guy invests $9,000 at 3% interest for 24 years. How much interest is earned over the 24-year period? Now, I equal PRT, which is 9,000 times 0.03 times 24. And I think that comes out to be 6480. Now, since this is your interest, the amount in the account is going to be principal plus interest. Just add the two and you get 15,480. By the way, is everybody still with me? Somebody say hi.
Still here.
Okay. I assume you are. Okay, good. Simple interest. I threw in another problem here. One of the problems you had to work on the homework was how long would it take to double the value of your investment? In this case, you're investing $8,000, pays 7% interest. So you use a formula, I equal PRT. In order to double what you start with, you need to have I equal 8,000. So you plug in 8,000 equal 8,000 times R, which is 0.07, times T. And you need to solve this for T. First thing I would do is divide by 8,000. And you get 1 equal 0.07 T. And T is equal to 1 over 0.07, which is 14.3 years. Now, could somebody tell me how we would set this up if you wanted it to triple in value? How much interest would you have to triple in value? Don't everybody talk at once. To have triple your money.
So would it be 14? Would it be 14%?
Oh no, I'm not asking. Oh, we're not asking for the interest rate you would need.
Okay.
How long would it take you to triple the value, still at 7%? Now, obviously, if you double in 14.3 years, you're going to have to take some more time to get triple. So what would the interest have to be? So that your interest plus your starting value was triple. I know you guys can do this. The interest would have to be $16,000, because the 16,000 plus the 8,000 would be 24,000, which would be 3 times the amount. So now you plug in 16,000 equal 8,000 times 0.07 times T, and now I divide by 8,000. Which this is a linear equation that you can easily solve any way you want to. But you get 0.07 T is 2, so T is equal to 2 over 0.07, which is 28.57 years. Rounded off to the nearest tenth to be 28.6 years. That wasn't in the homework, but I thought it would be a very simple thing to be able to do. Now, getting to compound interest, you're familiar with this formula. The future value of your account is going to be the present value of the account times this expression, which is the power of exponential function. You could also say the present value is also equal, is the principal. Usually what you first put in the bank is called the principal. And as the account grows, the amount in the account grows. And that's your future value at any time. And you already know what all of these are. you got to remember that N is a compounding periods. Could be 4, 2, 1, monthly, would be 12, daily. That's, can't remember whether it's 365 or 366. Depends on whether it's a leap year, right? Okay, let's work an example. You invest $24,000 in an account for 10 years. Find the value of the investment at the end of 10 years. And doing it simple interest. For simple interest, it's equal to principal times the rate times the time is 24,000 times the rate is 6% and the time is 10 years. If you multiply this out, you get $38,400. If you compound it annually, of course, R is going to be 0.06. T is going to be 10. And if it's compounded annually, N is 1. So the future value is going to be 24,000 times 1 plus 0.06 over N, which is 1. NT is equal to 10. So your exponent is 10. I'm going to go ahead and put this in the calculator. I hope everybody has this calculator here. I would put 24,000 times 1 plus, and I'm going to go ahead and do the fractional here, 0.06. In this case, the denominator is 1. And take that to the 10th power, assuming I didn't make a mistake. By the way, I would encourage everybody to check their work. Do this calculation twice and really be careful about what you put in the calculator. It says the amount is going to be 42,980.34. And notice with the compounding, you get quite a lot more amount at the end of the 10 years. Another example in which we have a compounding monthly, which makes N is equal to 12. Present value is 2,000. And T is equal to 5. NT is equal to 60. And so the future value is going to be the present value, which is 2,000. 1 plus 0.08 0.08, make sure you plug the correct things in. 0.08 over N, which is 12, to the NT, which is 60. And I'm not going to show every one of these on here, but let's go ahead and put this in the calculator. 2,000, parentheses, 1 plus, I'm going to use a fractional expression here, 0.08, divided by 12. In parentheses, to the 60th power. And that is $29,790.69. But I'm sorry, did I read that? That's not, just 29,7969. Okay, it's not 29,000. 29,7969. Now, read the problem carefully. I had 3 or 4 students on the homework ask me, how do you calculate the total interest when you're compounding? Well, the total interest will be the future value minus the present value. In other words, you started with the present value, you have a future value, the difference is going to be the interest. So we're going to use this same formula to calculate the future value and subtract $10,000 from it. And that'll be the total interest earned. So here, if it's simple interest, the interest is PRT. The principal is 10,000. The rate is 6% for 25 years. Just multiply that out and you get 15,000. Now we're going to do it compounded monthly. So we need to calculate the future value from which we will subtract the starting value of 10,000. So the future value is equal to 10,000 times 1 plus 0.06 compounded monthly. NT, N is equal to 12. T is equal to 25. So NT is 300. By the way, you could have the calculator calculate the NT, but usually I find it the simplest just to go ahead and figure out what NT is. We will do this one also. $10,000 times 1 plus 0.06 divided by 12. Let me delete that right parentheses. Notice you have to move it over so you can put the parentheses in the right place. So be careful. To the 300th power. And that is 44,000 44,649 and 70. 44,649.70. So we need to subtract 10,000. That would be PV minus 10,000. So that would be 34,649.7. Notice with compounding, you get over double the interest. Very powerful. Now, another example we worked is how much do you need to deposit now to have a certain future value? So we solve for future value in terms of, we solve for present value in terms of future value, and we get this formula, which looks exactly like the others, except you have a negative NT for the exponent. Example here, you want to have $4,000 in the future in 10 years at 8%. How much do you need to put in the bank now if it's compounded monthly? So that means N equal 12. Future value is 4,000. R is 0.08. N is equal to 10. So NT is equal to 120. So I'm going to let you guys put this in your calculator. It's 4,000. 1 plus 0.08 divided by 12 to the NT, which is 120. And I did this ahead of time. You'd have to put in $1,802.09. And of course, the last thing that we did is figuring out what payment amounts you would have to pay in order to pay off a loan. And here we have this formula. I'd be very careful to put this in correctly in your calculator. But here again, PV is the initial amount that you're borrowing, interest rate in decimal, time in years, the payment frequency, how many times per year you pay. Typically that's going to be 12, and PMT is the payment. Now, read the problem carefully to figure out what you need to put in the formula. You want to buy a $225,000 house, and you're going to pay 10% down and take a 30-year loan for the rest. How much is the loan amount going to be? Well, the down payment excuse my scribble. The down payment is going to be 10%, which is $22,500. So the loan amount, PB, is going to be $225 minus $22,500, which is going to be $202,500. So this is going to be the amount you're going to borrow and that you have to pay off in 30 years. So here are your monthly payments. That's going to be $202,500 times R over N. R is 0.05. N is 12. And it's 1 minus 1 plus 0.05 over 12. Everybody make a correction. There's an NT up here. I don't know why that didn't come out exactly right, but it's minus NT. That is the formula, minus NT. So make that correction on your notes. And NT, N is 12, T is 30, NT is 360. So we want to go to the minus 360 power. Now I'm going to go ahead and put this in my calculator, and I always do it twice, folks, just to make sure. But I'm pretty impressed with this calculator. We're going to go ahead, and we've got a fraction to do, so I'm going to start out with a fraction. And the numerator is going to be 202,500. And we're going to multiply that times 0.05 divided by 12. By the way, unmute yourself and tell me if I've made a mistake anywhere. It is not impossible. And then the numerator or denominator is going to be 1 minus 1 plus, I'm going to invoke the fraction here. Remember to go down and put the denominator in. That's 12. Then move this over to put the in parentheses to the minus 360 power. And if I didn't make a mistake, this should be our monthly payment, which is $287.06. Now, what are your total payments over the 30-year period? Now, everybody check this on your calculator. I'm going to bring my calculator up, and I'm going to just multiply. I'm just going to leave that number there, even with the 3787, and multiply times your 360 payments. That means your total payments that you paid for that loan over that period is $391. I got to bring it up again. By the way, I forgot to put this note in my sheet here, $342.96. So to borrow $202,500. So you made almost $400,000 in payments for a $202,000 loan. How much interest did you pay? You'll subtract the $202,500 from that. So we're going to go back up here and subtract $202,500. And that is the total amount of interest you paid, which is $188,842. And how many cents? 96 cents. So you paid almost $200,000 in interest over 30 years. Now, that is basically the problems we're going to be working. I wonder if anybody has any questions about anything. Is anybody still there?
Yes.
Okay. Did you have a question?
Well, I do have a question. It was from, I didn't understand one of the homework questions.
Okay. Did you bring it with you?
Yes. The questions say, how much would you need to deposit in an account now in order to have $4,000 in the account in 10 years? Assume the account earns 6% interest compounded quarterly.
Okay. Let's go back to the formula. How much you need to deposit to have a future value. Okay. Do you see this formula?
Okay. Yes.
Okay. You wanted $4,000
Yes.
in the future. And what was the interest rate?
6%.
106. And this is compounded
Quarterly.
Okay, so N is not 12, it's how many years?
For 10 years.
So NT, this is just like the one we just worked. except it was compounded monthly. You see this? You see this? This is the one we just worked, except it was compounded monthly.
Okay.
So now, uh, 0.06 divided by N, which is 4, minus NT. Okay, do you see this?
Yes.
I'm going to, everybody do it in their calculator. I'm going to do it in mine. And always check it, okay? Nobody that I know is perfect. Let's see, to the minus 40th power. Did anybody do this at the same time I did? Need to put in need to go back up. 22,505. Okay.
Okay.
That's how much you would put in.
Okay.
Okay, does anybody have another question? If you need to say something, unmute yourself. If you're not saying anything, you can mute yourself. Let's see, Stephen, okay, Kadija Kitchens and Stephen came in. Are you guys there?
Yes, sir.
Yes, sir.
Okay.
I was the one who just was asking about the question.
Okay. Yeah, when you popped up, I didn't necessarily recognize your voice. I apologize.
Oh, it's okay.
I want to make sure that one of the things that doesn't happen is that after everybody goes, it doesn't give me a list of everybody. So I'm going to take a picture of the screen here, which has everybody in here. I got William Turner, Kadija Kitchens, Charisma McCullough, Jennifer Castro, Jason Davey, and Stephen. What's your last name?
Parrish.
Parrish. Okay. Does anybody have another question?
No, sir. I'm good so far.
Okay. I'm very pleased with the homework results so far, except there were 3 or 4 out of 30 that didn't do all of them, and maybe even one person that didn't do anything. And I'm trying to figure out how I can help that person. But if you've done all the homework, if you've worked on the practice quiz, and if you had any questions about the practice quiz, looked at the video on how to work them, you should be in good shape. I'll be around throughout the week. If you have any questions in the future, you could text me, send me an email, take a picture of a problem and send it to me. Any other questions?
And what day would the test be this week? Thursday or Friday? Is that right?
Thursday and Friday.
Okay.
If you look at the I'm going to bring this up. Let's see. The way I would run this course if I were you, you don't have to go to my homepage, but go to the quantitative skills and reasoning page. And this tells you just about everything you need to know, what your daily schedule is. And it tells you the week of September the 2nd, you got test 1 on September the 5th or September the 6th. You need to take that. It will pop up on your web browser on MyOpenMath. And I'll be checking to make sure it does, to make sure everything's okay. So far, everything's been working fine for the homework. The other thing is you've got all these videos you can click on to watch with the notes, with the loan payments and the notes, link to the Zoom link, and I will put a Zoom link for the test review after I get it recorded and everything. So let's see if there's anything else. Notice you got your practice test, you got your practice video. When we get into test 2, we'll have the same thing going all the way through. I think you should be in good shape. If you have any more questions, anybody? No more questions. Okay, well then I'm going to wish you all a good afternoon. I'm going to stop the share and end the meeting.